Okay, I think yeah, we are online.
Yep. Yes, and we are live now. So you may want to move ahead and do the introduction. Yeah. Okay.
Okay. Well, thank you, Majid. Thank you for organizing this webinar for us on the deployment of algorithms with Scilab Cloud. So I'm here today, so with our colleague Majid, but also with my colleague here in France, Paul. Hello, everyone. Good morning, Paul. So what we have today for you is a kind of a live session around the deployment of algorithm on Scilab Cloud. I have 3 slides in order to introduce the subject of Scilab overall for those of you who don't know Scilab yet. So first of all, Scilab is a competitive solution, an alternative to MATLAB, but open source and free. We do have an alternative to Simulink for control system simulation, and Paul is actually developing this actively. So if you have questions regarding this aspect later on, we can discuss about it in a Q&A. Scilab has a worldwide community of around 1 million users worldwide. We register every month more than 100,000 downloads from scientists and engineers all over the world. So we're growing, and we developed recently a new cloud offering called Scilab Cloud, and it's basically enabling the deployment of applications. So we'll tell you a bit more about that in a few minutes, and Paul will show you concretely how it works.
Yes.
And last but not least, we joined the ESI group. And so Majid, for instance, is one of our colleagues in India. So now we have colleagues all over the world. ESI group is a French company, but with international reach. There's 1,200 people worldwide. And so I'm not going to tell you much more about ESI today. It's not so much the topic of the presentation. But if you have questions regarding ESI, we can also address this in a Q&A in the last part. So this should take around 30 minutes to 40 minutes, let's say, and it's mostly going to be hands-on with a few demonstrations. I'm going to go through what it also means in terms of commercial aspects, because well, Scilab being open source and free, we provide services around the software, meaning the development of applications. Here we're going to show you a very simple application, but we can do much more with Scilab in terms of development. We also provide training and support. And the cloud services is it's a commercial offering that we propose, and it's based on the number of users. So the starting point for this offering is at 200 euro per month. So it makes 2,400 euro per year, and it's starting with a starting pack of 10 users, and afterwards you can scale to more users, and you can either deploy it so on premises. If you want to have it on your own server, it's possible to deploy our Scilab Cloud with a container that we have as a technology in order to simply deploy it on virtual machines and servers that you have at your premises. Or what we do also is, and we will show you, it's a public cloud offering, so meaning that we are hosting the solution on our own, and you don't need to get involved with your IT in terms of deployment. So those are the 2 options, and I'll go through that a bit more afterwards technically. And also what we propose around Scilab now within ESI is a software solution that encompasses simulation overall, so pre and post processing of, for instance, finite element analysis, whether it's CFD, vibral acoustics, mechanical analysis, and so on. Also the coupling with third-party simulation codes, and the development of simple vertical applications. Now about Scilab itself, here is an overview of the 3 functional domains of Scilab. The first one being modeling and simulation. 0D, 1D, what we mean by that is basically with regard to compared to 3D simulation, it's mostly not in a defined geometric direction. And when we say 0D, 1D, it's mostly time simulation, so depending on time, dynamic systems. And here we can model those dynamic systems with a mathematical language. So Scilab is very close to the MATLAB language, and it's very close to the mathematics. And so you can produce data out of your algorithm, visualize them, optimize, generate code from the model that you defined in Scilab language. The second part being scientific data analytics. You start from the data, either it's simulation data, and then you can perform model reduction on those simulation data, or it's test and measurement data, for instance, and then you can produce some machine learning in order to go back to a data-driven model. What we call data-driven model is basically to make a data fitting out of your data, whether it's regression, clustering, or classification. So we have several kind of methods, statistical methods, and also post-processing methods. Oh, I can see Paul. Thank you for sharing your screen. Yeah, maybe you're in front of my presentation.
I hope I'm not too much in front. I'm gonna stop sharing.
Wait, maybe we can keep it for the live Q&A. Right. And here it looks like I can also point out to a region of my screen. So here the last part is what we're going to focus on today, is the development of application and algorithm in order to deploy them. So what we call an application is basically a set of algorithm, the data, and the user, the graphical user interface. So in this webinar, we're going to go shortly over what we already covered in previous webinars, is the deployment and development of applications overall, but also simply deploying only algorithm and data in the second step. So here I'm going to start by showing you here what we mean by application on the left side, and as I meant also simply deploying API. So and we'll go through the definition of what is an API, an application programmable interface, and this is simply basically deploying algorithms, so functions, Scilab functions, and the data that those functions are leveraging. So the first example that we're going to take is a weather application. We've already taken this example before. Basically, we're going to use data on the one side, algorithm and user interface, and going to deploy this application. So I'm going to hand it over to Paul, who's going to shortly summarize all of those aspects, and then we'll see how we can deploy a web service out of this example. So let me hand it over to Paul, and there you go. You should be able to present your screen now. So I think I see your screen. There's a bit of latency, so maybe.
Okay, so I have started Scilab. If you have already started Scilab, you can recognize the environment. On the left side, on the left panel, I have my file browser, which enables me to check which files I have on my system. In the center, I have what we call the console, which is in order to enter commands such as 1 + 1 = 2. Okay, so here is where I'm going to run my commands. And on the right side, I have my variable browser, which lets me keep track of all the memory that Scilab knows about. So what I'm going to start doing now is to load. So you can see that I have some CSV data files in my file browser. I'm going to load one of those CSV file. I have already entered the command, so I saved it. I'm going to call my result A. I'm going to use a function that is called CSV read to read a CSV file on this file, paris.csv. So it's the weather data in Paris. When I start this command, so now I have an A variable in Scilab, which I can see in my variable browser. And when I double click it in the variable browser, it opens kind of an Excel view of the variable, which contains all the CSV data. And I'm going to focus on the 12th column, which is the pressure value. And you can see that, so I can modify each value individually, but what's interesting for me now is that I can easily plot my data. So I have a lot of, I have a few different representations. If I go with the most simple one, here is what I get. So during the year, I have some pressure values. And now, as those values are a little too discrete for me, I would like to perform a linear regression on it from Scilab. So I am going to open now in Scilab regression script. So I open Synodes, which is the Scilab script editor. And I'm going to open what I have already prepared, which is my regression script. So it's called reg.sci. It contains a function that performs linear regression. And when I launch this script in Scilab, now I can call my function regr, R-I-G-R, and I call it, so this is a function now, and I call it on the on the A variable, and it's going to extract the 12th column, the pressure, and it's going to perform a linear regression on it. So I press enter, and I get a representation of my pressure again, and in red, the linear regression performed on it. Okay, so that's a good first step, which is the algorithm. The regression is what we're going to call the algorithm. And now what I want to do is to mask that all that command line instructions. And I want to create a small interface, user interface, to easily call my script on my data. So this is the second script that I have prepared. So if I go back to Scilab, I can dock my Synodes to Scilab. So now I have only one window. And I can open here the second script, which is called interface.sce, which contains only a few lines of instructions. And when I press play, I start this script in Scilab. It creates a small interface with only one button, very simple one. And when I press call my script, this is a button. And when I press it, it's going to run this command. So perform the linear regression on A. So when I click it, I get the same result as after calling my algorithm. And so now I am finished with my simple example, which is create an interface in order to mask an algorithm which loads some data. The second step now is to, well, the next step is to create a more complete interface, more extensive one. So I was in the data folder, and now I go back one level, and I am in what we call the weather application. I just load that application in Scilab. It's already prepared. And it's starting an application, which you can see it's just like my previous interface, but it's just with more buttons and other tweaks. When I call CSV read again on the Paris data, now I can analyze it. And you see that when I go to pressure, I see the pressure again, pressure values. And when I click regression, it performs a linear regression on it, just like before. So it's all in one window with a graphical view. And I have other.
You have also a slider. You can select
I have a slider, exactly, yes, that lets me slide along the time zone. And you can see that the linear regression is performed again on the data every time I change the values. And okay, so I'm going to validate a trend for each of the values. So when I get the green lights everywhere, I can predict the future climate. And so the result of the whole application comes down to the weather will be stable, fair, and dry. This is based on the 3 regressions performed on the 3 different values. Okay, so now I have my whole application. My objective now is to send it to the cloud, to cloudify it in order to mask the algorithm and all the code, and to give access to all the users. So I have sent my application, this application, to the cloud, and I have given access as an administrator to Jan as a user.
As a user.
Jan, I am an administrator and he's the user. So I'm going to hand it back to him, and you can see how it goes as a user. So where is it? So I'm going to hand it over back to Jan, who is going to show you how to use the application in the cloud.
So you should see my screen now. I am logged in on Scilab Cloud, and here I see my dashboard of applications. Here I've only one single application. Paul gave me access to this weather application. I'm gonna start it shortly, and you will see the results of this very same application in the cloud. And afterwards, we're gonna basically leverage only the functions out of this application, only the linear regression in the first step. And afterwards, Paul is gonna upload a new function, a new kind of analytics that we can perform. So here, the difference is also that compared to the application that Paul just showed you, I have access to different kind of data, different kind of basically, well, with a station here, they are, well, in the cloud, they are managed as different groups, and the data, depending on those different locations, are located in each of those groups. So here I have only access to the same application, but in Corsica, in the cities of Ajaccio and Bastia. But basically it's behaving exactly the same. Here, it's actually the exact same code that is performing here on the cloud, HTML rendering, and here you can select your data and so on. But it's the same code. Now what we want to focus on for the rest of the webinar is basically how to go from this kind of an application to a web API, a web service. So here, as Paul described to you, he developed an application with Scilab. He uploaded, that's what he did not show you, but we'll show you afterwards the administration interface. But we went quite quickly to the visualization of a simulation web app with a web interface. Now, the concept of an API in the web is basically just uploading a function, a Scilab function, without a graphical user interface, and this function will be well accessible. You can call this function as an API, as an application programming interface from any machine that is connected to the network. So basically, this gives you either the ability to broadcast your function to further users of Scilab, or any users, or people that could be using Python, any other kind of programming language, in order for them to leverage your know-how, your function from a different environment, and they can then integrate it also in their own application, whether it's a web application, whether it's a desktop application. We'll show you a few examples afterwards. And all of this can run either in a private cloud or a public cloud. So now we're going to go through the development of the development of a function in Scilab in your desktop environment. That's what Paul showed you. It's about importing local data. Here we're going to simply cover in the first place the example of a linear regression. So this is a script of only not the graphical part that is performing on the right side this plot, but only the algorithm out of it. And so basically this function afterwards needs to be integrated in what we call a toolbox. So you need to package your function here as it's displayed here, and then you can deploy it on the cloud. So what Paul did is he gave me access to this function, and I can show you how I can, well, basically call this function from, for instance, my Scilab environment. So there are a few new functionalities in the next release of Scilab that are not yet available, but I'm going to show you. Basically, you can do this kind of HTTP call. So it's using the HTTP protocol in order to call this API. And in the first place, what I'm going to do is here, I'm going to have login on the Scilab Cloud and have a token that I'm going to use for each of the different call of the API. Wait, this is not the test that I wanted to take. Yeah, this is more like the test that I wanted to take. So first of all, what I'm going to do is, he gave me an account, so I'm going to use this account, and I am going to first, so maybe you can give me the name of the API that, here, the URL. Here it's calling, I think it's test API is the name of the API. It's a development version, so you gave me the number of the development version. Yes, there's difference between development version and production version. So here we are first in the iteration between Paul and I on the development version, and he gave me access to this regress lin. So basically, this only the algorithm out of this function. So here I have some data, the same data, the sensor data, same kind of data that Paul basically loaded earlier. I have those data locally here, and what I'm going to do, I'm going to make a first call to this API, to this function with my local data. So basically, I'm sending him the data, the sensor data, and he's giving me a result that is here output output, and this is this vector that is, and if I plot it here locally, you can see it's the same result as in the application, only it's calling just the function. So this was the first example of what Paul uploaded. Now we're going to go through the administrative part of it. I'm going to hand it over back to Paul so that he can show you how he handled all of the uploading a new version of an API and then giving me access to it in the user management. So here, handing it back to Paul. You go ahead.
Okay.
So yeah, I see your screen again.
My screen. Okay, so this is my, as an administrator, this is my point of view. Okay, I'm going to Web Services, which is the API tab, and inside the API tab, I see all the running APIs that I have uploaded, and I am going to upload a new one named new reg v3. I'm going to get it from an archive. There it is. So prior to that, I have created a new scripts and zipped them on my desktop. Now it's uploading the new scripts. And once it's done, I'm going to be able to check the build status, check that the cloud has been able to load my API. So if I download the build process, I see that it has gone well. Okay, it has loaded the macros, and I see that I have two new functions that I have access to. So this was the regression routine, and this now is the new FFT function that I give access to which Jan will now use as a user. So I have uploaded my new functions, and now I can press play to make it live. And now Jan should have access to the new functions as a user.
So give me back the control, and I can show how I'm gonna perform the exact same scenario of testing your new API. Maybe you can just give me the number of the development version. I think
84.
84. Okay, we were testing before on the number 83. So now I am changing basically just the name of the function. Now it's called FFT on that in order to perform FFT on the data. And basically, so I'm going to use the same token. Here I don't need to authentify again. The same data. Now I'm going to send this. So it's answering in less time than it needs to talk about it. And now I'm going to plot the results just for you to see. So this is here a slightly better way to fit your data. Here you can see a sinus kind of data fitting that is resulting from a FFT, from a Fourier transform on the signal. So here, with this kind of a process, what we just showed to you, we have the ability to basically share functions with our colleagues, with our partners, with people outside of the company. The good thing is, what you might have mentioned, you might have seen, is that the whole time I was not able to see the code itself, what was running on the server side. So this was the intellectual property of Paul. He developed this new algorithm. It just gave me access to it, but I cannot modify it in any way. I can just run it. So basically, this was the first example, the first demonstration that we showed to you is with the API. This is a script that I just showed to you. Is a way to basically call this URL. And this URL is giving me access to his function, and I can simply send him the data here that I have locally, and afterwards get back the results. So I just showed you that in Scilab. Now we can go through a more evolved scenario where basically I want also to be leveraging the data management. So in this example, it's an example on a thermodynamic database that has been interpolated by NASA with some polynomials functions that I'm just going to show you. So there's two aspects to it. On the left side, you can see the results of one of the interpolation of those three thermodynamic functions, the first one being specific heat, second enthalpy, and the third one entropy. And those functions are given by a polynomial in T being the temperature, in Kelvin. And basically, in the function that we'll be calling as an API, there's some parameters, A1 to 5 in the first case, A1 to 6 in the second case, and A1 to A7 in the third case. So basically, all of those information will be stored on the cloud, and I will show you how we are storing here not only the model but also the data. And this is how the data looks like. So I'm going to go to here. I'm going to log off as a simple user, and I'm going to log in with. Oh no, I'm going to log into my administrative account here in the data management. So here in the data management, I've uploaded a term SOD. So here I can download it. You can see how it looks like in Scilab. So where is it? Let me browse through the demonstration in order to show you. Voilà. So this thermodynamic data, I can load it in Scilab, and this is what you're going to see is just what I showed you earlier. Okay, it's loaded. It's a variable m, and in m. So if I make a tree view of m, that's what you just saw earlier, is what I've shown you here. It's basically a tree with all of the different thermodynamic entity, aluminium, and so on. I don't know all of them, so I'm just going to go through the first one. And in this structure, it's a M list. I've stored the temperature on which we can apply the thermodynamic laws on this element and the different coefficients. So basically, in this first example, what I'm going to show you is how I can call this API from a web page. So here I developed a complete web page in HTML and JavaScript. So the HTML part, this is only those buttons and so on. So this here, I defined a way to identify, and here in the background, I'm not going to show you, but here I have access to, I hard-coded the authentication. I can log in. I can, in the first place, update the symbol list. So basically, the input is a JSON file, giving, okay, this is where I get in the data management my file, term.sod. This is where it's located. It's in my home. I can just as well also be sharing it in a group. So not only in my personal home here, I can, here as I showed you earlier, I have home, but I can also have group access to other groups and share it with others. And this is a token. So this is the input parameters that I sent. And I'm just gathering basically only the name of the entity. So this is what is feeding this pop-up list, this list. And here I can give in also the temperature in order to compute those three thermodynamic variables. And here I represent them in HTML with JavaScript. But basically, this is just to show you how we can integrate this function in a web page, in your own web page, in your own website, your own web application, and so on. So this was the first example. Now, the second example is also you can develop a Scilab desktop application that will be connecting to the cloud, and that will be basically performing all of the different, here, if I show you all of the different ways to call the API. So those are the script in Scilab, how we can call the API. In the first place, what I did is, yeah, okay, I can call with a token. Very well. Here I can also get the information here, what is in my in my data management. So here, for instance, in res group, I can see that I have here one file only. And what is its name? It's the term.sod. So if I upload a new file, then I will be able to make HTTP call to the API in order to know what's on my data management, and I can download it locally and so on. I can access to the data management through an API. Now the first call is I can also ask him what is contained in the symbol list. So here I'm just going to go and check out. This is what I gather as an output. And now the third API call would be to basically get the result in order to plot the different thermodynamic properties. So here, I'm not going to show you what is in output. I'd rather show you this example on a small application that I built in order to make the same thing as I did just now, but through an application. So I'm going to log in first. There's a first window that is asking me for my login. So, voilà. Now it's giving me back a token and the list, as I just showed, and I select the aluminium and I plot the element. And this is what I get, the exact same kind of curves for specific heat, enthalpy, and entropy. So it's just to give you an idea of a more evolved API, a more evolved example of application that you can deploy. So that's it for us today. Thank you very much for listening to us. We have time for Q&A. If you want to ask us some question, we can answer them. And now we can go back. Yeah, can be also sharing my. So we are next to each other.
Okay. Hi, Jan. This is Majid here again. Yeah, just want to make sure. First of all, thanks for the presentation. I hope we have some questions here. We have some time. So if anybody has any questions, please use the small hand icon in your go to webinar panel, or just type your question, and you know, we'll try to answer you.
Right. As Jan said, the cloud has some notable advantages, such as masking the code, so you can keep the property on your code, and it cannot be modified by the users. It can also hide some data that you don't want the users you only want the users to use and not modify or have access to. And it can also provide you with la puissance de calcul, computation power,
resources.
Yeah.
I see there's a question from Savas.
From Savas, that's right. Yeah. I'll just read out because he's typed in. So I'll just read out his question. He's asking if it's possible to access this presentation at a later stage, maybe download it from some website or something like that. So it's more about this presentation that you just showed. Would that be available, Jan?
We can make it available.
Okay.
I know there's a way you share it typically on the ESI website, right, Majid? In the resources.
Yeah, we can send it out through the email that goes out to the attendees. Yeah, we can do that.
It's also a way for us to share with you. If you want, you can, maybe Savas, maybe you can send me an email. You can see here ydb@esigroup.com. You can send me an email and I'll answer directly to you with a presentation.
YDB. Yeah, I think that is also good way to communicate. Yeah.
Yeah.
Okay.
If you have any questions,
okay,
you can contact me directly.
Also, our cloud service is already live, professionally live. We have customers using it right now, actually. So it's already tested and
you can all, I mean, we showed very basic example in order to walk you through it, but it's possible also for you to deploy much bigger applications. But we can also be supporting in this aspect.
Non, t'as eu accès à ce truc-là. J'ai pas accès, moi. T'as accès à plus de trucs que moi.
Okay, well, there's no further question. Maybe we can close today's session. What do you think, Majid?
Absolutely. Yeah, I do not see any more questions, but there is the email, Jan. Thanks for sharing your email. Like that, people can reach out to you if they have any pressing questions regarding this topic.
Okay, great. Well, thank you for organizing this, Majid, and thank you for all of you for participating. And we'll be looking forward to further discussion on this subject.
Superb. Have a great day, Paul and Jan, and to all the attendees who are here. Bye.
Thank you for your time, everyone. See you.